Good day, viewers. In this video tutorial, I'm going to teach you in less than 5 minutes mass per second that gush out from what? A tank or pipe or hose or any vessel. The mass per time of water that is gushing out. That's what I'm going to teach you in less than 5 minutes. Let's look at this question. An open tank holds water 1.25 meter deep. The depth of that water is 1.25 meter depth. If a small hole of cross section area 3 cm squared is made at the bottom of the tank, calculate I the mass of water per second initially flowing out of the hole. The mass of water per second initially flowing out of the hole. I the velocity water used to be gushing out of the tank. The velocity of the water used to be what? Gushing out of the tank. So coming here, they open the bracket and say we should take G acceleration due to gravity to be 10 meters per second squared. That's what they say we should take G. Then remember, density of water is 1000 kilogram per meter cube. That's density of water. That's what they gave you us here. But remember, in some cases they may not give you density of water. We needed to know this offhand. You needed to know this offhand in some cases because they may not give you the density of water. You needed to know the density of water and the acceleration due to gravity offhand. Let's go to what? Solution. But before we go to solution, if we have not subscribed to this channel, please endeavor to subscribe. Subscribe to this channel to help me grow my channel. Then comment, share, and what? Comment. And turn on the notification bell for what? Other video. Thank you. Let's go to solution straight. I'm going to divide the class this by 2. I say what? Solution. Solution. Then remember, we say the mass per what? Seconds. This T stands for what? Seconds. The mass per seconds which gush out from a tank or from a hole or from any vessel, the mass of water per seconds that gush out, this mass per second that gush out from what? Holes is equals to the what? The density of the water, the what? Cross-sectional area of that what? Hole, and the velocity in which the water is used to gush out. And I call it what? No need of putting word. I say density of the water, cross-sectional area of the hole, velocity in which it used to what? Gush out. Then you remember, this is the velocity. I cannot say that mass, but I cannot say but velocity which it used to gush out, but what? V, which is the velocity it used to gush out. This velocity which the what? The water used to what? Gush out is called escape velocity. Remember, escape velocity is a velocity which an object will use to go out of what? The acceleration. Against the acceleration due to gravity, you used to what? Explode out, which rocket used to go out of the what? Planet Earth. If rocket want to go out of the what? Planet Earth, we have to what? Check the escape velocity which you will use. So this V is what? Escape velocity, which is equals to what? Root of what? 2GH. This is called what? Escape velocity. This V, which the water is used to gush out, is as well called what? Escape velocity. I told you this is the density of water. This is the cross-sectional area of the hole in which the water is what? Gushing out from. Then this become the what? The velocity in which the water is used to gush out. And that velocity in which the water is used to gush out from the what? The hole is also called escape velocity. Using this to substitute for this man, I will have that what? Mass per what? Time is equals to what? Density of what? The water or the fluid, the cross-sectional area which the hole has, times what? the escape velocity, which is 2gh. So this become the formula we are going to use now. Then this is the mass per time, which they say we should calculate. Then the density of water is given to me as 1000 kilogram per meter kilo. Then the cross-sectional area, look at it, the cross-sectional area is given to me. Look at the cross-sectional area. They say the cross-sectional area, look over here, the cross-sectional area is 3 cm. We said come over here, 3 cm, which is the cross-sectional area. Remember that the density is the kilogram per meter. Are you going to say that? And the acceleration due to gravity given to me is meter per second. But what they give me here, 3 cm squared. So we have to use a uniform unit. Since this man is in meter and the acceleration due to gravity is meter per second, which is given, then now what we have in the area is centimeter square. I have to change this centimeter square to meter. I'm going to do that. Now we said 3 cm, 3 cm divided by 100. That's how we change centimeter to meter. Changing centimeter to meter we divide by 100. So if I'm changing this 3 centimeter to meter, I will divide by 100. But remember, the centimeter I'm changing to meter is squared. Therefore, I'm going to square this 100. You see the reason why I'm squaring the 100? Because the centimeter I'm changing to meter is squared. I'm going to square the 100. I'm going to have 3 over 10,000. 3 over 10,000. This 3 over 10,000, which will give me 0.003 meter squared. That will give me 0.003 meter squared for my area. Then now height. What do you give me as height? Height is given to me, look at over the question. The height is given to me as 1.25 meter. I will have 1.25 meter as the height. Then did they give me G? The G is given to me as 10 meter per second square. Look at the G given to me, 10 meter per second square. Then now, using the formula now, I will say the mass per time gushing out of the tank is given as density, the cross-sectional area of the hole, then square root of 2gh. Substituting the value, I will have the density is 1000 times the cross-sectional area is 0.003, then times the square root of 2, the acceleration is 10, times the height, which is 1.25, times the height, which is 1.25. I will have that my days become this time this will give me 0.3. This 1000 times 0.03 will give me 0.3 times square root of 2 times this will give me 10. 10 times this will give me 20. 20 times this will give me 25. Are you what I'm saying now? That will give me 25. And this will now give me square root of 25 will give me 5 times 5. And that will give me 1.5 kilogram per seconds. That's what is gushing out. 1.5 kilogram per second. That's what they asked me, the mass of per seconds initially flowing out of the hole. Look at the mass of initially flowing out of, which is 1.5 kilogram per seconds is the answer. Then the second question said I should calculate the velocity which the water used to gush out, which we call escape velocity. The velocity which the water used to gush out is escape velocity. I come to I. The velocity which the water used to gush out is the escape velocity. I will now say escape velocity V is equal to square root of 2gh. 2gh. Substituting the value, I will have that the 2 is times 10 times 1.25. And that will give me that my V is equal to square root of 25. Because 2 times this will give me 20. 20 times 1.25 will give me 25. And the square root of 25 will give me what? 5 meter per seconds. That's what he used to what? Gush out. This is the velocity of the water used to what? Gush out of the pipe. And that is the answer of the second question. This is the velocity in which the water used to what? Gush out of the what? The pipe. So this is what we have for you today. And if we have not subscribed, endeavor to subscribe, share to your friends, and see you in the next video. Thank you.